Going through the AC system. This is our third of 4 videos covering the basics of the AC system. In this one, we're going to cover the refrigerant flow and the components that make up the AC system. So 4 primary components that are going to make up the AC system. We're going to start at the top with the AC compressor. AC compressor on most vehicles is belt driven, so it's going to be located on the front of the engine. Coming out from the compressor, we're going to have a high pressure vapor. That high pressure vapor is then going to go to the condenser. The condenser is going to change it from a vapor into a liquid. So we already talked about we have to give up a tremendous amount of heat in order to change something from the vapor into a liquid. So we're going to have airflow going through there. We're going to have fans to make sure we have enough airflow to be able to remove that heat from the condenser. Now, if you're measuring the temperature of the inlet and the outlet, you should never find more than 50 degrees difference. Typically, you're going to find closer in the range of 20 degrees difference between the inlet and the outlet of the condenser. So where do we get that tremendous amount of heat removed from? Again, going back to the BTU and latent heat, that is the converting it from vapor to liquid. The refrigerant is then going to go from the condenser as a high pressure liquid to the TXV. Now, if you're familiar with the AC system, you'll know I already missed a component, and that's the receiver dryer, which we will come back and talk about that component later. So the TXV is a thermostatic expansion valve, and it's going to be the restriction that changes the refrigerant from a high pressure liquid to a low pressure liquid. And it's going to change how large that restriction is based on the temperature of the refrigerant. And again, we'll talk about this in more detail. So that low pressure liquid is then going to go into the evaporator, which you remember the evaporator is under the dash, typically on the passenger side of the vehicle. And all of the air coming into the vehicle through the HVAC system is going to pass through that evaporator. So while this system is running, that low pressure liquid is going to boil or vaporize inside there. The R134A is going to boil at about minus 15 degrees. So that evaporator is going to be trying to get really cold. But the TXV should limit it to right about 35 degrees, give or take. We don't want the evaporator to freeze up. But the air that's going through there, the ambient air, is going to remove that heat. The refrigerant is going to remove the heat from the air that's going through there. Then the refrigerant is going to leave the evaporator, go back to the AC compressor as a low pressure vapor, and continue its cycle on through the system. So the system is sealed up. So long as there's no leaks, it can go for years. I've seen a car 30 years old that the AC system had never been touched. But now we have a conundrum. We're going to use the ambient air and cool down the refrigerant, and at the same time we're going to use the refrigerant to remove heat from the ambient air. So we have to go back to that understanding of the BTUs and the latent heat in order to understand what's going on here. So the refrigerant, as it's coming out of the compressor, is going to be 140 degrees, give or take. Obviously, the higher the engine RPM, the humidity, there's going to be some ranges on there, but we're going to use about 140 degrees for this example. And that 140 degree refrigerant is going to go into the condenser. The air coming through there is at 80 degrees, and so we can use the 80 degree air to remove the heat from out of the refrigerant and change it from a vapor back into a liquid. Now, once the refrigerant goes through the TXV, we drop the pressure, which is now going to allow the refrigerant to boil. And with that drop in pressure and the lowering of the boil point, now the refrigerant is going to get really cold. And so now with the refrigerant down getting really cold, we can use that really cold refrigerant to remove heat from out of the air. So is the nature of the refrigerant, that the pressure that it's at when the system is charged the way it's supposed to. If you look at the pressure, there's a pressure temperature chart that you can tell what the temperature of the refrigerant is by what the pressure is. Compressors. So looking at more detail, if you look at the one in the lower right hand corner here, this is a piston compressor. You can see that red piece on the inside there. That's what they call a wobble plate. So as it turns, it's going to move those pistons back and forth on the stroke. And it's going to draw the refrigerant in on an intake stroke, push the refrigerant out on the compression stroke. But there's a valve on there, a couple valves, that are going to allow the refrigerant to come in from one side, pushed out on the other side, and that's how we're going to compress and circulate the refrigerant. Over on the left-hand side is the newer design. This is what the manufacturers have gone to, and that is a scroll-type compressor. So that scroll-type compressor is going to move in an elliptical pattern and push the refrigerant through the system. This is the best way of doing it. So if you compare a piston-type compressor that we have on the right to the scroll-type compressor on the left, that scroll-type compressor can move the same volume of refrigerant at the same pressure, but for 1/3 the horsepower load. So we're looking at a change of the compressor putting a 15 horsepower load on the engine to now only about a 5 horsepower load on the engine. So it is possible that on some vehicles, if you roll down the window and the air coming into the car, that cab of the vehicle is going to act like a large parachute and put a load on the engine. So it is possible that you would actually put less of a load on the engine by running the AC system than it is by lowering the window. To engage the compressor, what the manufacturers have been doing since the 50s is, if you look at the piece on the right-hand side there, that's a large electromagnet, one of the largest electromagnets that we have on the car. The pulley, that's going to stick up inside that pulley, so belt-driven, there's a bearing inside there, and it can freewheel around that. If it's the electromagnet is shut off, that pulley's going to spin, the compressor's just along for the ride. That plate that's on the outside is going to be drawn in when you energize that electromagnet. So most of them have a ground wire, and when you energize it, there's a relay that puts power to that electromagnet. And typical draw is going to be around 4 or 5 amps when that engages. So once it engages, you'll hear a loud click as that plate gets slammed up against the pulley that's on there. And now the compressor is going to turn at the same speed, or it's going to turn with the engine. If you speed up or slow down the engine, you're going to speed up and slow down the compressor. So that's how they've been doing it. And there are some vehicles that AC doesn't work, and what you're going to find is that clutch just got burned up. So compressor, there's nothing wrong with compressor, it's just the clutch is burned up. But since we live in a replacement society, you're going to replace the whole compressor. Now, the manufacturers a few years back started switching over to a clutchless compressor. And that's what you're looking at here on this picture. When you start the engine, compressor's turning. Compressor is going to be turning all the time that the engine is turning. Now, if you have something catastrophic go wrong inside the compressor, it's going to seize up. The belt's on there pretty tight. You have the potential of actually seizing the engine. But that pulley that's on there is actually a breakaway pulley. So if the compressor does seize up, that breakaway pulley is just going to snap, and it's going to allow this pulley to spin, but compressor's toast and needs to be replaced anyway. Now on this particular one, they're talking about a variable displacement compressor. And if we come back here to this wobble plate that we have in the red here, so right in there, they have the ability to adjust that wobble plate so that it can lengthen and shorten the stroke. And that's going to be your variable displacement compressor. So There's our compressor with no clutch, meaning it is going to run the whole time that the engine is running. Now, if I don't want the AC on, that's going to put a load on the engine, which I don't really want. So what they do is in between the suction and discharge ports that are on there. And what we have over here is our suction discharge ports. And connected in between there is going to be a passage. If you don't want the AC to work, that passage is open and refrigerant's just going to flow out the discharge right back into the suction. It's not going to put any load on the AC compressor. It's just going to spin, but not build up any pressure. Once you want the AC to work, there's a solenoid that's on there that's going to close off that passage, and now the refrigerant's going to flow through the condenser, receiver dryer, TXV, evaporator, and back to the compressor, so we have AC working as normal. If you have a hybrid or an electric vehicle that has AC, since we're not running the motor, but we still want AC, this is what the manufacturers have gone to. It's a AC motor. It could be either a DC or a three-phase AC motor, high voltage, so orange wire. And orange wire means we're greater than 70 volts to run that compressor, and you can see this is a scroll type compressor. So with this setup here, compressors are not going to be on the front of the engine. The engineers can put that compressor anywhere on the car that they want to hide it. The compressor requires lubrication. When we had our R12 system, everybody was using mineral oil to lubricate the compressor. When we went to the R134A refrigerant, the R134A refrigerant was not compatible with the mineral oil. It wouldn't hurt the mineral oil. Mineral oil wouldn't hurt the refrigerant, but it wouldn't pick up the refrigerant and carry it through the system. So they had to go to a PAG oil or to an ester oil. On the PAG oil, that came in 3 different viscosities, 46, 100, or 150. What viscosity it used is determined by the AC compressor. When you add oil to a system, you have to make sure that you're putting the right oil in there, the right viscosity oil, or you could damage the compressor. On our R1234 refrigerant, they're using a PAG 46 oil. It's critical that you have the correct viscosity and the correct amount of oil. So if you have a leak on the system, as the refrigerant leaks out, it'll take some of the oil with it. So oftentimes you have a leak in the system, you need to add an ounce or 2 of oil when you recharge the system. So you don't want to put too much oil in there, or the AC system's not going to work the way it's supposed to. It's actually going to act like it is an overcharge of refrigerant. So the AC compressor has no reservoir inside of it. Some of the older ones did, the newer ones don't. At least not on the automotive side. On the heavy duty side, yes, they have a reservoir on some of them. So for this reason, it's very critical that it has the refrigerant in order to pick up the lubricant, carry it through the system, and lubricate the compressor. Now, if you start a system up and it doesn't have enough oil or doesn't have any oil, you can burn up the compressor in as little as 4 seconds. So make sure you have the correct charge of refrigerant in there before starting that system up. Condenser. Condenser is going to sit out in front of the radiator on most vehicles. Some manufacturers will put it next to the radiator, but most of them, this sits out in front of the radiator. Which means when you run the AC system, the heat that you remove from the cabin of the vehicle, it's going to be deposited in front of the radiator. So it is going to cause the engine to run hotter with the AC on. So the 2 lines coming in, one is coming from the compressor, the other line is going to be going to the receiver dryer and then to the TXV. As the refrigerant passes through this, it's going to, the airflow through there is going to remove the heat, changing it from a vapor to a liquid. Now, some of them have what they call a subcooler on it. And when you look at it, it's hard to identify, but what there's going to be is typically another section down here. So you'll see a little bit of a break in there, and then it looks, just like the condenser continues. But what that actually is, it's going to act like a second condenser, and it's going to, again, remove a little more heat. The more heat that it can remove from the system, the better the AC system is going to work. Now, on some of the newer vehicles, this is over the last several years, if you look at your high pressure line and low pressure line that are going to your TXV and evaporator, the two lines join into one. So you can see on this system where they become one line. But if you look at the cutaway, you'll see there's actually still two separate lines just in one housing. And this again is going to act like a subcooler. We're going to use that cold refrigerant that's on its way back to the compressor to remove a little more heat from the refrigerant that's going into the evaporator, improving the performance of your AC system. You'll find this on more and more vehicles because the manufacturer can actually get CAFE credits from the federal government by having these on there. Alright, so here's the part that I skipped over earlier, and this is the receiver dryer. The receiver dryer is going to do two jobs. The primary job, and if you're taking notes, make sure you get this down. The primary job of the receiver dryer is to make sure that it is only a liquid that is going to the TXV. So the TXV will not work correctly if it has a vapor coming to there. So looking at the image in the lower left, you can see the refrigerant that's coming in. If there's any vapor that came through the condenser, it's going to go to the top of the system and it's just going to stay in there. We should have this mounted close to the radiator of the car so that we have some airflow to help cool it down and change that gas or the vapor back into a liquid. The kind of speckled stuff that you're looking at over here, this is a desiccant bag. And desiccant is going to absorb moisture. So we can't have any moisture inside this system. If you open up a system, air gets in there, it's going to take some moisture in there. You have to get all that moisture out. But a little bit of moisture that we have left in there, the desiccant will help take care of. But this desiccant is designed to actually remove the moisture from out of the refrigerant. If there is moisture in there, when it gets to the TXV gets below freezing and it's just going to ice up and plug up the system. And so what you're going to end up with is an AC system that starts, works for a little bit, and then stops until that TXV warms up enough and melts the ice inside there, and then it'll work for a little while, and then it'll stop again because it keeps plugging up with ice. So we need to make sure we get all the moisture. So number one job of the number one job of the receiver dryer is make sure only a liquid getting to the TXV. The secondary job, remove moisture. Alright, here's our TXV, our thermostatic expansion valve. They come in a number of shapes and sizes, and most all of them very rectangular in shape. So the smaller opening that's on there, that's going to be your liquid line coming from the receiver dryer. And that liquid refrigerant is going to be going inside of the evaporator. The larger opening is the return line going to the compressor. That's going to be our vapor. And on that side, it's actually going to be the same temperature that it is inside of the evaporator. So there's a thermal valve or a thermal bulb inside there that as it gets too cold, it's going to restrict the opening. So cut down the flow of refrigerant, and it's going to help warm up the evaporator a little bit. If the evaporator gets too hot, it's going to open up more and allow more refrigerant to come in there. So as the engine RPM increases, it's going to try to shove more refrigerant through there. It's going to restrict it down. Start idling, and it's going to open it up in order to try to maintain that temperature just above freezing. Now again, if you have a fan on low, not much air going through there, it's not going to remove a whole lot of heat, so that TXV is going to restrict the opening. When you turn the fan on high, a lot more air going through there, removing a lot more heat, so it's going to open it up more. So the TXV can adjust to ambient temperature, engine RPM, and fan speeds to help maintain that temperature of the evaporator just above freezing. Here's your evaporator. Again, it looks similar to a heater core. I'm going to go back to this last slide, and you can see the evaporator on this picture here. Oops, not there. Right there, the TXV actually bolts right up to the evaporator. So you can see where the TXV is going to go on this one. Refrigerant going in, it's going to boil inside there. Remember, it's going to get very cold as it changes from a liquid into a vapor, and we're going to absorb the heat from out of the air that's going into the car. So this is going to be in that HVAC box under the dash, typically on the passenger side. Now, here's the air conditioning part. It is going to remove more than heat from out of the air. It is also going to remove moisture. And this is critical. We'll talk about this on the next slide. But as well as removing moisture, it is also going to remove pollen and dust from out of the air. So my wife has allergies. Sometimes they get really bad, and especially when we go down to the Willamette Valley, which was one of the highest pollen content in the United States. So she just gets miserable sometimes. But when we were young, we couldn't afford air conditioning at our house. So we would hop in the car, we would go for a drive, turn the AC on, and turn it on that recirculation. So we're bringing the already conditioned air back through there. And after about 5 or 10 minutes of driving, her allergies would begin to clear up, because the AC system not only removes heat, it also removes moisture, pollen, and dust. So what do we do with that moisture? Oops, got ahead of myself. Talking about the moisture content. If you have ever stopped to consider at what temperature are you most comfortable? Most people are comfortable right around 72 degrees. So this image showing you in New York City, 72 degrees, 90% humidity. If the person's in the shade, most people will be comfortable with that. However, that same person, if they were to go to some place where the humidity level is at 30% instead of 90%, 79 degrees will feel the same. I remember being out in the desert one time. I was riding a bike and I was going, man, this air feels really good. And I was shocked to get by the bank and find that it's 90 degrees. But as long as I was in the shade with less than 10% humidity, 90 degrees felt okay. It doesn't anymore, but it did when I was younger. So you don't have to cool the air as much. If you can dry the air, you can make a person comfortable. And the less temperature change, the less shock there is to the body. So now, what do we do with that moisture? Underneath the car, passenger side, right by the firewall, there's a drain that goes underneath there. And I'm sure you've seen it. It causes some people concern. They go to the store, they run in, they come out. A little while later, and there's a big puddle of water underneath the car just behind the right front tire. Normal condition when you've been running the AC system. The moisture that are removed from the air, it runs out underneath. Now, every once in a while, that drain plug drain tube can get plugged up. Now, the moisture that's coming off the evaporator is going to leak out the heater outlet inside the car. And the customer complaint is going to be, my car leaks, but it hasn't rained for a week or two, and they're complaining about the car leaking. So when you get that complaint of the floor is wet or the carpet's wet on the passenger side and it hasn't been raining, this drain tube is where you need to be looking to see if it's plugged. And the first thing I do to find out if it's plugged, I take an air hose and blast the air up through there. So just give a shot of air up inside there, and the junk that's plugging it up will be lifted up out of the way, and then some water will run out, and now I know it needs to be cleaned out. So that's it for this presentation, and we got one more to go.